Hello students, welcome to ATC. In this video, we will see about the construction of Turing machine. First, we will see what is a Turing machine. See, Turing machine is a modified version of PDA and it is more powerful than PDA. Instead of using stack as in PDA, Turing machine uses the tape to store the symbols. And Turing machine is a generalized machine which can recognize all types of languages through regular languages. Let's say, it can recognize regular languages, it can recognize context-free languages as well. And a Turing machine, it is a mathematical model. Again, it is a virtual machine and it consists of an infinite length tape divided into cells on which input is given. And it consists of a head which reads the input tape. A state register stores the state of the Turing machine, and after reading an input symbol, it is replaced with another symbol. Its internal state is changed and it moves from one cell to another to the right or the left. And if the Turing machine reaches the final state, the input string is accepted, otherwise it is rejected. So Turing machine is a seven tuple. It has a seven tuple notation, which is nothing but Q is a set of finite states. Delta sigma is a set of input alphabets, and then tau is a set of tape symbols, and then delta or D is a transition function. Q naught is a start state. B is one new symbol what we are adding here. It is a special symbol indicating a blank character. Okay, because we can indicate that, okay, in case there is a blank B, that means it is the end of the string. Then F is nothing but the set of final states here. So Turing machine model, a Turing machine consists, it looks like this, okay, which is having an infinite tape like this, and it can have any number of inputs, can be read or written. And the control unit will be controlling all the input sets. Okay, so tape is used to store the information and it is divided into number of cells like this. So you can make out, okay, all the cells, and each cell can store the information of only one symbol. That means one cell has one symbol, and the string to be scanned will be stored from leftmost position of the tape. The string to be scanned should end with a blank space. The tape is assumed to be infinite. Okay, and read-write head, we have something known as read-write head here, and it can read a symbol from where it is pointing to, and it can write it into the tape to where it points to. Control unit is nothing but the reading from the tape or writing into the tape is determined by the control unit. That means the read or read action will be controlled by this control unit. The different moves performed by the machine depend upon the current scanned symbol and the current state. What are the various actions which are performed by the Turing machine are: first one, it can change the state. Then second one, the symbol pointing to by read write head can be replaced by another symbol, and read write head may move either towards left or right. Okay, so let's see how to construct a Turing machine. And I'm taking one example of a context-free language, 0 power n, 1 power n, where n is greater than or equal to 1 here. Okay, so some of the valid strings, n, when n is 1, we get w, the string as 0, 1. When n is 2, 0, 0, 1, 1. When n is 3, 3 zeros followed by 3 ones. When n is 4, 4 zeros followed by 1, etc. Some of the invalid strings also I should consider. Okay, 0, 1, 1, because it's not, okay, the number of, first of all, this language, 0 power n, 1 power n, all the zeros should come first and then only all the ones. And number of zeros should be equal to number of ones here. Okay, so how actually the Turing machine works, let us see. Initially, let us assume this is the thing we have in the tape. Okay, so 0, 0, 0, 1, 1, 1. I'm taking n as 3. So the string will be 0, 0, 0, 1, 1, 1. And I'm terminating with a blank character. Okay, initially the read-write head will be pointing to 0 now. Okay, then what happens, as soon as it reads 0, let us assume that we will replace it with x now. Okay, and the pointer head will be moving to right. and the pointer head will be moving to right. So how do we show it on the transition diagram is that, let us assume Q naught is a start state. Upon reading 0, it will replace it with X and it will move right, and it will move on to the next state. So it has moved to right. Okay, next thing we will see, I am reading 0. Okay, so once I read 0, see the concept is I got 1 0. So for the first 0, I will have to go to right and find the matching 1. That means 1 I will have to search now. Okay, now as such I'm reading the second 0. So once it is 0, I don't have to alter the contents. Let it be just 0 only, but I should just move right. So this will be a self loop saying that, okay, 0, do not change it with anything, but just move to right. So it will be any number of times. Okay, so we have a transition that is a self loop. Okay, so 2 zeros twice this will be done, and and I'm in the same state. Now what happens? I'm trying to read 1 now. So once I read 1, that means what? Okay, I have got a matching 1 for this 0 now. Okay, so what I do, I will I will change the state and I will replace 1 by y now. Okay, and I will move, since I got the matching value here, I will move left. Okay, so once I get 1, the replace it with y and move left, so it will move left. Okay, how many times it has to move left? Till I get x, because the next 0, I am sure that once I read the x, that means the very next symbol will be 0 again. So again I start reading all the zeros, and I will not do anything. I just keep moving to left, but of course I have changed the state here now. So I just keep on moving left. Now again I will move left. Okay. Now what am I having? X. I am reading X. So once you read X, that means what? Okay, this is anyway the matching values are found for every X. I should have a matching Y. Now, once I read X, now what am I supposed to do? I will change the state and I will move right. Okay, again the same procedure continues. Like 0 for 0, I should change it to X, and the same stuff goes on. So now what I do, once I read X, I will change the state to Q naught. Okay, I will not change the content, but I start moving to right. Okay, I start moving right. Now I got the first second 0. Okay, so what am I doing? Once I get 0, what am I supposed to do? Replace it with X and shift right. Correct, I will change it with X, I will move right. Okay, this is anyway we have got it. Now for 0, yes, this transition also I have. If I have 0, I will not do anything, I just keep moving right. Okay, I moved right. Now I have y. Okay, I don't have any transition as such written now. Okay, so if I have y, again I should not do anything. I just keep moving right till I get the next one. Correct. So my current state is q1, and I will read y. I will not do any change in the state or the value. I just keep moving right. So y right. So I am here now. Now what happens? I'm reading 1. So for this x, I have got, for this 0, I have got 1. That means for this x, 1 has to be replaced by y. So this procedure I am repeating. Now once I read y, where should I go? To left. Yes, I moved left. Then again I got 0. Okay, so I was here. Yeah, I'm reading y now. So once I read y, again I should not do anything, I have to move left here. Okay, so this is one more transition we have got. So I moved left. Now what do I have? 0. So if I have 0, what I am supposed to do? This one. Okay, I just keep moving left. Now I have got x, so I have to change the state to Q naught. Then I should move right. For 0, I replace it with x, move right. If I have y, again move right. If I have y, again I move right. 1 to be replaced by y. Okay, move left. Okay, then I have y, so move left. Yes, now I have x now. So once I have x, I came to x, the q naught. Again, I start moving to y now. Do you have from q naught any transition to y? No. So I will have to have a new state y for y. So q naught upon reading y, do not change anything, but change the state. Again y I have. So what am I supposed to do? Make a self loop for this. Okay, for y. Do not do any change as such. Okay, again I move. Now what am I reading now? B. So for B, once I get B, I will change the state, make it as a final state, and then move right. Okay, so once I get blank, that means okay, I am reaching the final state. Okay, so this is the transition diagram for Turing machine. Okay, so once I got this transition diagram, it is very easy to write the table, that is to draw transition table. How many states I have? I have Q0, Q1, Q2, Q3, Q4. Thus, what is a start symbol? Q0. What is a final symbol state? Q4. Okay, so start state is Q0, final state is Q4. Mention them, and then Q0 upon 0. Where is it moving to? It is moving to Q1. So Q1, okay, and then X and R. Okay, 0 XR we have. So 0 means under 0. So what you have to do is you make a table in such a way that you have one column for the states, and then all the tape symbols you write 0, 1, X, Y, B. These are all the tape symbols. So 0, for 0 you are writing. Upon 0, what are we doing? We are changing the state to Q1, and we are replacing it with X, and we are moving right. Okay, so q naught upon 0 we have got. Do we have any q naught upon 1? No. So left blank. Q naught upon x? No. But q naught upon y? Yes, I have. I'm moving to q3. No. So q3 and y and r. Q naught upon b? No. Similarly, q1. For all these things, you draw the transition. So q3 upon y I have, q3 upon y I have, q3 upon b also I have. So q4, nothing. It is left blank. Okay. So this is about the transition table. Okay. So the next one is we are just looking at the instantaneous description. Just before that, let us see for an invalid string how the Turing machine works now. So this is an invalid string 0, 1, 1. Now what happens? I'm reading 0. Okay, so this has to be replaced by x, and it is at q1 now. Okay, now what happens? I'm reading 1, so it will replace with y, and then it has moved to q2 now. It is at Q2 here. Now what is happening? I'm reading it. It has to shift. It has to move left, right? According to this one, once it has replaced 1 with y, it has to shift left. So I am at x now. So once I am at x, okay, I'm reading x. Now what is happening? It has moved to Q naught now. Okay, it has moved to Q naught, and I don't have any, I'm at Q naught now, but one, do you have at Q naught any one reading? No, that means I'm stuck. I'm stuck. I'm not at all reading blank here. Okay, we will see one valid string 0, 1b. Okay, so 0, okay, replace with x. I am at q1, then I am replacing 1 with y. I am at q2, but I am shifting left. Okay, I shift left, so I am coming to x. I'm reading x now, and I'm at q0 now. So I'm here q0, and then I'm reading y. Do you have any transition from q0 to y? Yes, I have. Okay, from Q0 to Y I have. So Q3. So Q3 upon B, yes, I have one more transition, and I'm in the final state. So this is how it will be read. Okay, and let's see the instantaneous description. So unlike the ID described in PDA, the ID in Turing machine depends upon the whole string and the current state of the machine. Okay, so let us see this one. We will take the example 0011 here. So ID for the string 0011, let us see. Initial ID will be Q0, okay, Q0, then 0011. Okay, this is the initial ID we have. Okay, now after this, what is happening is, now from Q0, what am I reading? I am reading 0. Q0 upon 0. What am I doing? I am changing the state, and where am I moving to? Right. Correct. So my current state is Q0. Okay. So I am moving. I will change 0 to X. Okay. I think I can write it here. 1 I will write it here. So my current state is Q0, okay, and my symbols are 0011. Now what is happening is Q0. I am at Q0 and I will replace. I am reading 0. So once it is 0, I am replacing it with X, and I am replacing it with X, and I will move right. Correct? I replace it with X and I will move right. I will move right. So the next ID will be X you are writing, then it has moved right, no, Q1, and then 0, 1. So this is only to indicate that it is moved right. Similarly, once I read next 0, what is happening? I will not change state, but I just keep moving right. So X0, and it has moved right. Okay, and now what is happening is I'm reading 1. So once it is 1, you are changing the state to Q2, and what are we doing? We are moving left. Correct. So then what happens? It moves left. That means Q1 was here. To the left means to the left of this 0. So that is Q2 comes here. Okay, so X is there, then Q2, then 0 by 1. Because Q1 is here, to the left of it, to the left of its symbol means to the left of 0. Okay, now what is happening is I am reading, uh, yeah, here I changed to Y as well. Now I'm reading 1. Okay, so once I read 1, again I should not do anything. I will have to just move left here itself. Okay, so in the exam you don't have to write all these things, just write these things. Okay, now I'm reading X. So once I read X, do not do any alteration, no change, but you move right. Okay, then you are reading 0. So once you are reading 0, you are changing the state to Q1. You are replacing it with X, you are changing the state. Okay, now you are reading Y. So once it is Y, do not do anything, just move right. Once you read 1, change the state to Q2 and replace it with Y, and then move left. To left means to the left of this Y. So Q2. Okay. Then after that, again I'm reading X. Again you have to shift left. Now I'm reading X. Again I have to once I read X, I should not do any change, just move to right. So to the move to the right of this Q2 means here it will come. Now what is happening? Y I'm reading, so it will move right. Then again Y I'm reading, it will move right. Finally it will read blank. No, once it read blanks, that means I have reached the final state Q4. Okay, so this is the final ID.